Math Blast 18. I can identify prime and composite numbers. Look at the numbers below. Shade each number that is prime. A prime number is a number that has exactly two factors. Numbers that have more than two factors are considered composite numbers. So here, I want to shade the numbers that are prime. 32. 32 has 1 and 32 as factors. If those are the only two factors, we would consider that number prime. However, I know that 2 is another factor of 32 because since 32 is even, then 2 is going to be a factor. So 32 is a composite number. 4, again, if 1 and 4 were the only factors of 4, that would be a prime number. If I can determine any other factor of 4, it's not going to be prime, but instead will be composite. And guess what? Since it's an even number, 2 is going to be another factor, making that composite. 7. 1 and 7 are factors of 7, and those are the only two factors of 7, so it is a prime number. 12. 1 and 12 are factors of 12. Since 12 is an even number, I can also say I know that 2 is a factor of 12, making it a composite number. 45. 1 and 45 are factors of 45. Now, I can't use that third factor of 2 because 45 is not an even number. But I do know another divisibility rule. 5 would be a factor of 45 because any number that ends in 0 or 5 is going to have 5 as a factor. So 45 is composite. And 1. 1 is a factor of 1. Now hold on. There's not two factors there because it's just 1. So we don't consider that number prime. And there's not more than two factors, so we can't consider that number composite. 1 is not considered prime or composite. Fill in the chart below with 4 different composite numbers that are between 50 and 60. Well, since I want them to be composite numbers, I need them to have more than two factors. And I'm going to use that idea of even numbers. I know that all of my numbers will have 1 and the number itself as factors, and since they're even numbers greater than 2, they're going to have a third factor, that factor of 2. So let's use 52, 54, 56, and 58. I can multiply multi-digit numbers. Solve 62 times 34. We're getting pretty good with an area model here, so I'm going to draw an area model. I'm going to make it have 2 columns representing 60 and 2, and I'm going to have it have 2 rows representing 30 and 4. And now I'm going to need to find the area of each of the rectangles here. So this far right top rectangle here is going to be a 2 by 4, which is 8. I have 60 times 4, which is 240. I have 30 times 2, which is 60. And I have 30 times 60, or I could think of that as 3 tens times 6 tens, which is 1800s. Now I want to add all the parts to my product. 240 plus 8 is 248. 1,800 plus 60 is 1,860. I'm going to add these together. I get 2,108, and that is the product of 62 times 34. I understand angles are measured with reference to a 360-degree circle with its center as the common endpoint of 2 rays. A circle measures 360 degrees. If the circle were divided into 4 equal parts, what would be the angle measure of each part? I'm going to show the center. I'm going to divide that into 4 equal parts. And we were already told that the whole circle is 360 degrees. So we want to share that 360 degrees equally among 4 parts. And so I know that each part is going to measure 90 degrees. 90, I can show that as a multiplication sentence. 4 groups of 90 degrees. That's 4 times 9 tens. I could write it as that way too. 4 times 9 tens. is equal to 36 tenths, which is 360. And I'll put my degrees sign there. So again, each angle measure or each sector of that circle when divided into 4 equal parts will measure 90 degrees. On the back side, I can determine the measurement of missing angles. Determine the measure of angle ABD. So angle ABD. Ray BA is lined up with 0 degrees as the exterior measurements, and we are going to measure around until we get to angle BD, and it looks like it's right past 85 degrees. Right here, it's going to be at 86 degrees, which matches what I see as the acute angle we're given, and an acute angle I know needs to measure less than 90 degrees, so we're good to go here. I can determine the measurement of an unknown angle. Determine the measure of angle ABD. So here, angle ABD is part of a larger angle. It's part of angle CBD, which we know measures 90 degrees. So angle CBD equals 90 degrees. And I know that angle CBD, that whole 90 degrees, minus the 41 degrees that were given, gives me angle ABD, the one we're trying to figure out. So with that in mind, let's say 90 degrees minus 41 degrees equals angle ABD. So what is 90 degrees minus 41 degrees? 49 degrees. So that is our missing angle, angle ABD. I can classify triangles by sides and angles. Identify the triangle by sides and angles. So in terms of sides, an equilateral triangle has all equal sides. An isosceles triangle has at least 2 equal sides, and a scaling triangle has no equal sides. Now I can see from the triangle we're given, based off of these 2 tick marks here, that those 2 sides are equal to each other. So we're going to call this an isosceles triangle, at least 2 equal sides. Angles. A right angle measures exactly 90 degrees. We are given a right angle here. So we know this triangle, it has a right angle. It's called a right triangle. If all the angles are acute angles, the triangle would be an acute triangle. And if the triangle were to have an obtuse angle, then the triangle would be called an obtuse triangle. So the most specific name for our given triangle is an isosceles right triangle. That's all for today, math friends.